Hi everyone, it's my honor to give an oral presentation at IEEE Sensors Conference. My name is Xiyu. I'm a third-year master student at Zhejiang University. Today I'm going to talk about an integrated flexible multi-sensing device for daily urine analysis at home. This presentation will be divided into 4 parts. First, the background. Urine contains various indicators, which potentially indicates the health status of people. Odor, color, as well as the composition of the urine of the patients with kidney disease or metabolic syndrome differs significantly from that of healthy people. So we can get a lot of information through urine analysis. In fact, urinalysis is widely carried out as a reference of diagnosis. Here are some common ways that people take in a urine analysis. For instance, the 14-item urine test strip can detect 14 indicators of urine, but it has a qualitative readout and the accuracy is uncertain. Meanwhile, for a more reliable outcome, people usually take a clinical urine analysis at hospital, and the collection of 24-hour urine analysis is usually carried out on patients, which is a golden standard. But the process is inconvenient and time-consuming, which cannot be done at home. With the growing awareness of personal health, it's necessary for people to have an easier way to monitor their urine health. Many scientists have paid great attention on developing a household urine analysis device. Smart toilets have also emerged as a health monitoring device. The Lab 1 proposed a smart toilet system for personalized health monitoring via a computer vision. This system has powerful features while it integrates a 10-parameter urine test strip for biochemical analysis. The right one demonstrated an inexpensive self-powered visual electrochemical sensor for urine glucose monitoring, utilizing the benefits of filter paper while only measuring one indicator. Based on our previous research, we decided to build a household urine analysis device prototype, which should include 4 properties. First, easy to use. Older people need more frequent urine tests, so the testing process must be simple for them. Second, flexible. The sensor needed to be flexible that can fit different situations. Third, multi-parameters. More indicators allowed for a full assessment of urine health. And electrochemical sensors were adapted to obtain a more reliable result. Fourth, wireless data transmission. A Bluetooth module was adapted for data transmission to a mobile phone. So a device with simple tube structure is designed. This is the schematic of the device. It is designed to be attached to a toilet surface or anywhere in the restroom. It consists of a S-tube and a flexible sensor and a PCB. After the design, we've done some simulation to optimize the structure. The S-tube is the main part of the device. The left half is the detection area, which is capable of retaining a volume of approximately 15 milliliters. And the fluid in sensing area can be totally replaced in around 5 seconds, according to the simulation. 300 milliliters is enough to replace the fluid 6 to 7 times to ensure an accurate result. Next is the design of the sensors. Urine is a complicated fluid that influenced by many factors, so we aim to build a multi-sensing sensor. Despite of creatinine, urea proteins, studies have shown that the level of ions in urine is also an indicator related to hypertension. Hypertensive patients with high 24-hour urine sodium to potassium ratio in compared to those with low ratio showed a higher risk, higher 24-hour blood pressure, and even more, a high spot urine sodium to potassium ratio is associated with a greater risk of stroke and potentially associated with cardiovascular event. Urine pH reflects the patient's renal function. A metabolic syndrome patient may have a lower urine pH. The elders are prone to diabetes, and there may be a higher probability for the elderly patient to have diabetes who has chronic disease, including hypertension and kidney disease. So urine glucose monitoring is indispensable. Above all, we choose sodium, potassium, pH, and glucose as the detection target. The electrodes are designed to be highly flexible to fit in the wall of the tube. So the polyimide film was chosen as the material. The multi-sensing sensor was designed as the picture. The sensor was made by a screen printing process with 3 layers. It has 6 electrodes, including 4 working electrodes and 2 reference electrodes. Preparation of the sensors is accordant with previous research. The iron sensor was modified with iron selective membrane, and the glucose sensor was modified by the glucose oxides. Open circuit potential and amperometry were recorded in measuring ions and glucose respectively. The electrochemical workstation was used to test the electrode performance. The sensitivity and repeatability tests were carried out on glucose, pH, sodium, and potassium. The results are shown in figures. The detection range of detection range of glucose is 0 to 1.8 millimole, and 4 to 8 for pH, 8 to 256 millimole for sodium, and 1 to 64 millimole for potassium. The detection range covers the normal range in urine, so it's capable of use for urine analysis. This is the design of the printed circuit board. Same experiments were carried out using the assembled circuit board on electrodes that had already been validated by the electrochemical workstation, and the results show that the circuit board was capable of testing and processing these 4 parameters. We also test the Bluetooth performance. Effective distance is 12 meters and 0 packet loss rate at 0 dBm and -6 dBm. One 3.7 volt battery can power the system for more than 24 hours. In conclusion, this device achieved a good sensitivity and linearity for detection of glucose, sodium, potassium, and pH, which is capable for urine analysis. And this device shows a great potential in urine point-of-care testing, especially for health management of the elders. It also has the Bluetooth function that can send the data to mobile phone, which allows tracking long-term changes based on daily records. That's all for the paper, but in the future, we will further enhance the device in 3 aspects. First, optimize the structure. That's all for the paper. But in the future, we will further enhance the device device. First, optimize the structure of the device, such as improve the material and downsizing, or improve the circuit board performance. Second, optimize the sensors, such as improve the linearity or integrate a volume meter. Integrates a flow meter to calculate volume of urine, and introduce more indicators such as Brentini-Ura. It is true that the demand on household health monitoring device, like urine analysis device, will increase greatly in the future. That's all for my speech. Thanks for your attention.